Hello, Diamonds in the Rough. So in this video, I'm going to talk about formula for the linear equation, which I've been using a lot in the previous example, a high level overview which we were doing. And I promise you that I will explain that formula somewhere. And that is the day-to-day that we go through the visualization, understand how that formula is derived. Like there is x into x transpose inverse multiplied by x transpose into y, right? That gives you the perfect weights for your machine learning model, right? And to do that, if you remember that example which we did from this mobile evaluation, right? How we can know the price of old mobile phone, right? How you can sell your phone, what will the value for it, right? So there was few examples which I have used. So basically those examples is something called features. Just like we have 16 pixel value for self-driving car example, right? We had like 9 or 10 pixel values, you can say in terms, but these were those features, right? And this was the y value which we were predicting. The new price was 1000, size of the phone was 6 inches, the age was 3 years old, screen was something, if one is AMOLED, other is TFT. This is the battery in mAh, 3000 mAh, headphone, jack is available or not, front camera, what megapixel for the front camera, back camera 13 megapixel. If it falls in the Sony, Apple, Google or something, this branded, or then other rest of the companies will be zero or something like new companies, and then you get the price accordingly, right? So these are the prices were given. So goal was to have a predict function where I pass on these values and get this output. So this is for known. Our goal was to like new phone comes, right? Now you want to test your phone, so you will give me all these features. I'll input that features into my function and I'll get that y value. So that is the product which we were trying to make. So, and we use this formula theta is equal to x transpose into x inverse, and then x transpose multiply by this kind of formula we use to find the theta like of size around 8 or 10, something like this, the same size of the feature, right? Where we actually multiplied and got the result. But to understand the derivation of that formula, what we want to do is we want to compress this example into a smaller subset so that you can understand the math behind it. So instead of using this 10 or 10 or something features, what if I told you I only use this feature, or maybe this feature, age and then price, I'll tell you. Just tell me the age, I'll tell you the price, or maybe this only new price. Just input this value and then give me output this. Don't use this one. Yeah, this will lose a lot of information, but for this sake of example, to understand the derivation, we'll use a simple example. So similarly, we created another data set where x was 1, think as one of the features, and y is the price you want to find, something like this. So goal is to create a predict function where we have to, like, if I input some new number, I should know the what is the output, and it could read through the pattern, right? And there we'll understand, while solving this problem, we will understand how the formula was derived, right? So you can plot this point. If you remember a function coordinate video, there we can plot it. So if I plot this as a points, x1, 1, 6, 2, 12, 13, right? And then draw a line over here. Then you probably understand that if I just draw a straight line over here, right? If I just draw a straight line over here, this will be my prediction function, right? And how I can find the, if you see in this example, the weights which you are trying to find is equal to the slope of this line, right? And this we have already learned from our previous example. If I find the rise over run thing for this example, rise over run, right? If I find just rise over run for this part, right? I can just rise is this value, right? Whatever the difference is, and then I'll find the slope. That slope basically tells me the weight, right? If you remember this from the previous videos. So that will give us my prediction function. But problem is that this kind of method only works when your points are aligned into a straight line, and I can draw a line like this. But if an example is something where this is not from this, I've just changed this point somewhere here. How would you find a line which will go? Because if you try to find a straight line, this might join these two lines, you will miss this one. Maybe then you will join these two one, then you will miss this one. If you join these two one, you will miss something like this, right? So there is very hard. So you need to find a straight line between somewhere which is very equidistant from all these points, so that you can get some kind of good fit kind of thing, right? And that slope will become your new weight for this example. And for bigger example, if you have more feature, basically then you have to find 2-3 points, right? That you don't have to worry, we will see in the future videos. So how can we do, like, how can we find a solid answer for that, right? How can we do that? So we're going to continue. There is a way we can do that. You have already learned, just you haven't seen into it in action. Like you already learned differentiation, right? Maximum minimum solution. We're going to use similar kind of method to understand this. So we need to find that weight. If I start from here, the perfect weights to fit this example will be somewhere when it is aligned. It is around 6, but that we have to see through. We have to find through formula that we will understand, right? If you remember how we can do it, we need to find that weight and then use it into predict function. Predict function basically will take the theta value, that is the weight we call it. Sometimes we'll call theta, sometimes we'll call weight. Both are the same thing. And then whatever the new input is, like 4 or something, I'll pass and I'll get my result. And if I able to do this, if I able to find this theta or weight, I probably like have solved this solution, right? I've got the solution. How we can do that? We can use, first of all, we'll create this loss function. If you remember, we have learned about loss function is basically whatever these points are, right? If you pass in, just pick out some random theta, let's say theta was 12 or something, and then you pass this x value 1 over here. Whatever the solution you get, subtract it from the original solution. See how far or how near you are from the actual result. And whatever the solution you get, the modulus, just remove the sign, because sign doesn't make a lot of sense in this example. And sum those differences. If those differences are little, or if it is very close to 0, then you are like, you have reached at a good golden theta value where you don't have any loss. Basically, where at that point your predictions are actually matching the original result. At this point, we can say that your model has learned all your examples and it's ready to predict the future example without any help or something like this. But problem is this, we want to change into a derivative function or something, and then we have to derive it. So modulus doesn't have a method to derive or something like this, right? So what we do is, what the modulus is doing over here is removing the negative signs or something like this, right? We can replace it with a square function, right? Instead of this, because square does the same thing, it just doubles the unit. But in the end, the goal is to minimize the loss, and it doesn't make sense even if you square it. So if you square this part over here, instead of modulus, you will get this loss function, right? And if I further solve this loss function, sometime this prediction function, some people will use H as a notation, hypothesis function, something like this, right? So in few of the courses, maybe in the end-range course or something like this, you will find H has been used on a lot of other books as well. So you don't have to mind if I use P as a predict function. This is basically this function I'm writing over here. H is also this function, P is also. So now we have wrote this thing, and now I can actually input these values over here, right? So now over here, h x1 by theta, basically what is happening in multiplying and writing. So I have replaced with, instead of function, their outputs, right? And then we can input all these values. So x1 is basically this one point, basically the difference between first set of pair over here. Inputting all those values, I'll get 1 theta minus 6, 2 theta minus, and whatever the theta, random theta I want to put, you'll get the solution. But this is a loss function, right? And we want to find this theta. So it looks like an optimization problem, right? You can input lot of different thetas over here, and you will get, like, if I start with 1, if I input 1, I will get around value, some 500 value. So at 1, I'll get loss of 500. If you input your theta as 1 in this prediction function, you will get a terrible result, and your differences will add up to become 500. But if you go second, you will got some around 4. So if I just plot this loss function, right, it looks something like this. And if I just simplify this loss function, right? What we have plotted, the simpler way to plot this function is basically 14 theta square minus 168 theta plus 504, right? This is the loss function. And how we can find theta, that we already learned that basically this loss function saying tell me that like theta value where I have the least loss, right? And what if I say that the rate of change of this loss, the way this loss is changing, right, with respect to this theta value, where this becomes 0, right, at that point you will get the theta where the loss is minimum, right? That we have understood from the derivative applications of derivative, right? Where the slope is 0, at that point usually we say that whatever the maxima or minima is always like 0, right? So over here, when we know that where the rate of change of loss function with this theta becomes 0, like where there is no change in the rate, right? If you see over here, it is changing pretty fast. Over here it is changing pretty fast in opposite direction. Over here it is also changing pretty fast, going from 100 to 150. The loss is changing really fast. At this point loss is not changing, right? At that point we have seen that you will get the best theta value where the loss is 0. So actually we can derivate this thing and assign 0 to it and solve for theta. If we do that, we'll probably find those best theta. As we can see, it is 6. So we derivate this thing, this one 504, as we assign 0 to it, 504 will get cancelled, and then we are left with this value. No, sorry, when you derivate this 2 will come forward, 14 become 28, minus this theta, this in derivative you will lose this part, 168 will come over here, and once you derive this thing, assign 0 to it and you can solve for theta, I'll probably get the 6 value. So this way actually we have found our golden weights without doing the trial and error. We have seen the previous example where we were doing the trial and error and we use this formula, right? Never understood where the formula came. But over here I just simply did it from the scratch without even using any formula. I created a loss. Goal is to find this theta and build this predict function. You don't require this all process while using into the real world, while giving the solution. This is to reach this beautiful theta, to find this theta. So we made a cost function, right? Optimization function, and this loss function is made from only this prediction function only, right? Once you differentiate and assign 0, you'll find this theta during this optimization method. This was for this example, right? How we can find a generic formula this thing. So that we'll understand, and that was the goal of this video. You can validate this value and you'll see that theta is like solve it, you'll probably get loss is 0, right? So you'll see how so we can generalize this formula for like any x values, right, or any y values. So once you differentiate in this thing, differentiate loss function with respect to theta. So theta is a variable over there. You can think rest of them a constant like this. So 2 will come forward. As you can know, x squares derivative is 2x. So this 2, like, over here we are using chain reaction. If you haven't aware about chain reaction, kindly read about that. And this 2 will come forward. Then x1 will solve over here. It will go like this. I expect to understand this derivative. So once you do the derivative, this part you will get this thing. And over here we are trying to find this generic formula. So I will not replace any of the variable with these points, right? Because we don't want a solution for this example, but for overall x and y values, right? And once you solve furthermore, you can see this pattern is basically, I can write the same equation in terms of summation. I hope you understand summation. Summation is basically when you have multiple additions, right? You can think this as overall one thing, this overall one thing, this whole thing, and they have pretty much common. So you can see x is 1 over here, x is 2 over here, x is 3 over, and the rest of the things are very much same. So you can write this in summation form like this. If you don't understand, please go through some example how summations work. Basically, a long list of additions like this. These are when separative addition can be simplified like this. I can again from here I can go back like this. If I just input, this is a kind of loop in programming. So basically loop through these values. Once you put x is equal to 1, you'll get this value. Once you put x1 1, and after end you have to add additions. So I can pretty much write this thing as xi 0 minus y xi, right? As you can see, x1 2 3. Like if I resolve this, I'll probably get this one. And as you know, why I assign 0 is because we want to find this theta value where this thing is the minimum, the loss is minimum, right? And we want to derive a formula from here. So that we'll see. And if you remember our GPU versus CPU video, right, where we have learned that matrix multiplication can also be like written and it could be faster way. So if you just think this x value, right, x1 2 3 like this, it's basically this value, this whole column vector kind of thing, right? And then this theta, x minus theta minus y value. So this y value is 6 12 18, right? This will also become a column vector. So this x is a column vector, is multiplied with a scalar value, or you can think matrix even with only one column and one row, this value minus y, and this x is being multiplied with each of thing, right? And this we can write in transpose, because once you write this thing in x in transpose, basically when you do this multiplication, this matrix multiplication, you probably find this summation thing that we have seen our previous example as well. Like whenever we do transpose and multiply each other, you will probably get this multiplication some kind of thing. So I'm just telling, if you are finding it hard to understand, I can give you a solution maybe in comment section or something if you are not able to understand. But this is your homework. If you just resolve, take x as this column 1 to 3, multiply with theta, which is a 1 by 1 matrix, or you can think scalar at this point, minus, because of they are of the same size, this x column, y column, it could be literally subtracted 1 minus 6 5 or whatever you get, and whatever the solution you transpose it. So if you resolve this thing, you will probably get this value, right? If you solve this matrix solution, you will end up into this kind of equation, that I promise you, and you can do it as a homework. But our goal is to not do that. The goal is to find this theta, so we can substitute. How we can substitute this theta? So if I just substitute and solve this thing, theta, I will probably find theta is equal to x transpose minus 1 x transpose y. And this is a formula I've been using to find those golden bits. In this case, the feature size, like only one features was there. If there was two features, you will probably find a list of array or something like with 2 elements. That theta will become 2 elements. So you can solve this part. I did had solution for this, but I was quite lazy to just code this thing and do it for you. But I hope you are smart enough to understand these substitutions. If you're not able to understand, please do write in comment. I'll probably share it. Okay, so that was it. This way we have found this formula, and you can now use it for any kind of x. If you just make it into a like this table or in a matrix form, your x could have multiple features, 2 features, like 2 columns like this, and then you will have to transpose and multiply with itself, find the inverse, then again transpose and multiply with y values, and whatever your solution will get, you'll find. So in this case, we required only one theta because there was only one feature. If let's say to another example, I have 2 x values over here, x1, x2, something like this, like 2 features, like new price or size of the phone or something like this, and this will be the price. In that case, you will get 2 theta value, because we are solving matrices. So matrices could have multiple elements. This theta will be also a matrix. I'll get some value. When I solve this, we got this single matrix, 1 by 1 row with 1 column. And 6. So this is a generic formula which we have derived from this small problem, and this is same. So in what the other feature, if you remember the self-driving car over there, this was also same format, just that there are more pixel values. Those were the features for x, and those will become feature, like there will be 16 of these like x values like this, and then you have to predict the y values. Same, that is also kind of a matrix. X is a matrix, y is a matrix. Solve it, you'll get the solution. For mobile evolution, that was also the same. So I hope you understood it. So next time, let's say now we have found our beautiful theta, how we can use it in the next example. Let's say I wanted to find when the x is 4, what will be the prediction? So we can use our prediction function, and the theta which we have found is 6 I can pass. So this input will goes 4, and the theta which we have found with such a complex way, we can use that value, and basically the prediction function multiplication in this example. When you do that, I'll get this value 24, which makes sense, right? So I hope you understood this formula, how it is derived. I literally did a lot of shortcuts over here, but it is pretty much doable. If you just solve this part, you will get this equation. So I hope you understood this, and let's see you in the other videos where we can, so where I will do is basically instead of having one features, I will add one more feature. So some people call it single variable linear equation, right? And then the multivariable linear equation. So I just did single variable. In a lot of courses, they don't call it single variable. There will be two variables and then they call it a single variable. For me, I think that is not being understood by lot of people. But for me, I think I consider it a single variable. I feel this makes more sense when you have only one theta to find it. So that is it. And we understand why required another theta, like 2 thetas or multiple x feature, how we need more thetas or something like this. So that we'll probably understand. So see you in those videos. I love to hear your comment, opinion, or you have understood or not. Any problem you can see in the comment. Any suggestion you can write. That really motivates me to make another video or to improve on the future videos. So do write your feedbacks if you want to continue watching more videos that fits your narration, right? So that way I'll try to fix a lot of things. And yeah, so see you in the next one. Bye bye.
Thank you for all your support.
You. Who are you?
My God! I'm gonna become stronger than anyone around.